In this video, we're going to find the arc length of a circle. So we've seen this formula before. The arc length is given by this, and I gave a long explanation of why this formula was the case. So if you haven't seen this formula before, then track back to one of the earlier videos. And we've seen examples. For example, in the case of y equals x squared, we worked out this arc length here from anywhere from here to here. We could easily do it for the case of y equals x squared because we could easily find dy by dx, and then later on we could easily integrate it, because the reason why we could do it with this was because in the case of y equals x squared it was easy, but when it came to a circle, our knowledge of integration wasn't good enough. But now that we've done lots of integration, hopefully we can tackle it now. So let's try and find the arc length of a circle. So let's say we're trying to find the arc length of a circle from 0 to a. So in this case, from 0 to a in the x direction. Okay, so looking at the formula, the arc length is given by this. Looking at the formula, we need to find dy by dx. So the equation of a circle is given by this. We need to know dy by dx because we need to know dy by dx here. So rearrange this. So y squared equals 1 minus x squared. Square root both sides, it would then give you this, plus minus. But we're only concerned with the positive one. So let's discard the negative. So looking at the formula, to find the arc length, we need to know dy by dx. So y equals this thing here. So now differentiate it. We need, looking at the formula, we need to know dy by dx. So now we are trying to find dy by dx. So starting from here, rearrange it so it becomes this, and then square root it. So that will then take you to here. Okay, so again we are still trying to find dy by dx. So reimagine this as this. And then when you differentiate it, use a chain rule, differentiate it, will then give you this. Tidy this up, it will give you this. So dy by dx equals this thing. So looking back at the formula, to find the arc length, we need to know dy by dx. Well, dy by dx is given by this. So now looking back at the formula for the arc length, we need to square dy by dx, meaning we need to square this. Well, squaring it means you times it by itself. So it will become this. Hang on. So you're multiplying it by itself. So top times top, that would be x squared, and then bottom times bottom, it will be 1 minus x squared. So if you square this, it will become this. So this from here, that will then take us to here, and then now hang on. Now imagine so here you've got one block taking away another block. Imagine this block as exactly the same divided by exactly the same. Imagine this one here as this, and then now the two denominators are the same, so we can merge these two together. And then here you've got a minus, and here you've got another minus, so they cancel each other out, giving you this. Okay, so now tidy this up. Remember, if you square root a over b, that's the same as square root of a over the square root of b. So now from here, that will then take you to this. Well, square root of 1 is 1. So it simplifies to this. So now it's just a matter of integrating this from 0 to a. Now to integrate this, we couldn't do it before because our knowledge of integration wasn't good enough. Now we could easily, integrate this. If you've forgotten, then to integrate this, always keep an eye out for something of this form: x squared plus a squared, or keep an eye out for something in the form of square root a squared minus x squared. If this is the case, then when you integrate it, it will give you this. If this is the case, when you integrate it, it will give you this. Because if you differentiate arctan, then it will give you something of this form. If you differentiate inverse sine of whatever, it will give you something of this form here. So to integrate it, it will then give you this. Integrate this, it will then give you this. Now we are trying to integrate this. We are trying to integrate this. So keep an eye out for something of this form or of this form. Well, if you look at this, here you've got a square root 1 minus x squared. So that's of this form here. 1 squared minus x squared, and then you've got a square root. So really to integrate this, we should use this. Integrate that, it would be inverse sine. Okay, so integrate this, it would be this, and remember we are evaluating it from 0 to a. So that will then take us to here, and then this thing here is 0. So the overall answer is given by this. So what that means is that if you look at the diagram, this length here from here to here, the arc length is actually arc sine of a, whatever a may be. Okay. Sorry. So this here is your final answer.